This is part 1 in a 4-part series of web seminars related to controlling a brushed DC motor using a microcontroller. This web seminar will focus on the basics of brushed DC motor construction and some common characteristics. So let's begin. During this web seminar, I will discuss the main components of a brushed DC motor and how these components work together to function as a motor. We will also explore 4 types of brushed DC motors and compare common characteristics between them. So let's start off with the brushed DC motor basics. A brushed DC motor is made up of 4 basic components: the stator, the rotor or armature, brushes, and commutator. First, let's look at the stator. As the name implies, the stator generates a stationary magnetic field that surrounds the rotor, and this magnetic field is generated by either permanent magnets or electromagnetic windings. Next is the rotor, also known as the armature. The rotor is made up of 1 or more windings. When these windings are energized, they produce a magnetic field. The magnetic poles of this rotor field will be attracted to the opposite poles generated by the stator, causing the rotor to turn. As the motor turns, the windings are consistently being energized in a different sequence so that the magnetic poles generated by the rotor do not overrun the poles generated in the stator. This switching of the field in the rotor windings is called commutation. Brushed DC motors do not require a controller to switch current in the motor windings. Instead, it uses a mechanical commutation of the windings. A copper sleeve, known as the commutator, resides on the axle of the rotor. As the motor turns, carbon brushes slide over the commutator, coming in contact with different segments of the commutator. The segments are attached to different rotor windings, therefore a dynamic magnetic field is generated inside the motor when a voltage is applied across the brushes of the motor. The brushes and commutator are the part of the brushed DC motor that are most prone to wear. So, as the rotor rotates inside the stator, the brushes rub the different segments of the commutator, supplying a charge to that segment and its corresponding winding. As the brushes pass over the commutator gaps, the supplied electrical charge will switch commutator segments, thus switching the electrical polarity of the rotor windings. This will create an attraction of the different polarities and keep the rotor rotating within the stator field. This process will continue as long as a supply voltage is applied.